Nobody? Nobody else is bringing a friend next week? One. All right. We're going to double our numbers. So do we have any community announcements?
Hey guys, I'm Anna Sherman. I work at Carbon 5, but I also organize Codex X. There's an event tomorrow for Elixir Bridge. It's like a very easy intro into Elixir and Phoenix. We'll get to build something cool. So if you're interested, you can sign up on bridgetroll.org. Find the one for Chattanooga. It's the only one. And sign up. Yeah, so the Install Fest is tomorrow, and then the bridge is actually all day on Saturday. And then next week, Friday and Saturday, is Gig City Elixir, which is a functional programming conference that's coming to town. It has Elixir in the name, but it doesn't just deal with Elixir. They've got big names from Haskell and Clojure and other functional programming languages. If you're interested in functional programming, you're like, I've never done it. I'm an OOP person. That's okay. It's pretty introductory. There's some deeper talks, but it's like for people who are interested into getting into functional programming. So if you're interested, that's next week, Friday and Saturday. And then Startup Week is all like starting, I think tomorrow or on Saturday. I'm bad with that date, but all next week is Startup Week, and there's a whole bunch of events. So I think you can go online and look that up, and there's a schedule for that. So.
When's the next JavaScript meetup? In a month from last night. Yep. We have a Python user group. The next one is November 19th. It's Monday, the third Monday of every month over in the large conference room. So if you're interested at all in Python or want to come bash us, bring it. Today we have Braden giving a talk on Unity for developers. Has anybody done any type of game development? Anybody interested? I'm super interested in this. Yes, I love the show of hands here. Welcome, Braden, everybody.
Well, Justin stole my first question I was going to ask to get a feel for everything.
You're welcome.
So my name's Braden Carter. I am currently a UI and gameplay engineer for Happy Giant. We specialize kind of in AR games. I have experience doing social games and serious games as well, which are social games are if you guys had your Facebook, your Farmville craze, all of those feeds that popped up on your post, that was me. I'm sorry. Serious games is more, for instance, an example for right now is I'm developing a game for special needs teens to get them oriented on what average day life expectations are, such as showering in the morning and things like, and just kind of that day-to-day routine. Another one's Cold Stone Creamery, if you guys love ice cream. They actually had a game commission years ago to make sure that their employees rolled the right amount of ice cream. So to start off with is Unity is a game engine. A game engine is basically a backend that handles all of your rendering, your physics, your input, things of that nature. The very first reason you should use a game engine is if you don't want to use one, you're still going to use one. You need a game engine to build a game. It's that simple. There are some frameworks and such that you can use, but in reality, you're going to make that physics, that rendering. It's just part of the nature. So why not use one someone has already built for you instead of spending 2 years plus trying to make one for yourself, which focuses on write games, not engines. As a game developer, most people always have like, I've got the great next game. I swear, I promise they do. And so spend the time writing that game, figuring out the core mechanics. Games are an iterative process. You have to build them. You got to play them. You got to test them. You got to go back in. You got to change them. That's just the nature of how they work. So rather than building your engine and fixing bugs with your engine of this doesn't look right, fix this isn't fun, not this doesn't look the way it's supposed to. There are plenty of game engines out there that you can use. Unity is just one of them. I personally, I've worked with it for 5 years now, or at least full time. I've worked with it before then, back when you had to write your own GUIs. It's come a long way since then, but if you're like, shooters, third-person shooters, Gears of War, Call of Duty, things like that, Unreal Engine is fantastic for that. That is what it was designed on. All of you Unreal Tournament people, I know I'm dating myself. Not that there's a huge young crowd here, but that's what that engine was developed for, was Unreal Tournament, and it's come from there. But at its core, it's designed for shooters. Unity is kind of a blank slate. I'll get into that a bit later. But another one, the next point is, at this point in time, most game engines support multiple platforms. Unity, Unreal specifically as well, both support iOS, Android, Xbox, PlayStation, PC, Windows, you name it, it's there. The downsides of you picking out a game engine to use and not building your own, however, are you're going to have to use the engine. And a lot of engines don't let you mess with its core roots because it's their product, it's whatever it is. So if it doesn't do what you want it to do, you're screwed most of the time. Some of them do allow you to have access to the source code. I believe Godot is one of them, where that's an open source engine. You can change what you need. Other ones will let you dig into them, but it really depends. Like Unreal is a really big engine that a lot of games are built off of, and they have a whole system around it, so you really can't touch it. You just got to work within the confines. And then the big one is, if you ever do make it big, you make the next Stardew Valley, which one guy did, made millions of dollars at this point. They're going to take a cut. Granted, the cut's not normally too big anymore, and when you're making that size money, it's just a drop in the bucket, but you have something to be aware of. I believe Unreal takes, I have it on the next slide. Unreal takes 5% of gross after 3,000 per game per calendar quarter. So anything after that is up to you, or they're going to take that from you. One of the reasons I like Unity is because they don't. Unity is free. They don't take revenue share anymore. They cut that out. All their expectation is if you make over $100,000, they want you to buy their Pro membership, which is $25 a month. If you make over $200,000, they want you to buy Plus and Pro. So the Plus membership is $25, Pro is $125 a month, but when you're making $125,000 or $200,000 a year, that's really not a big ordeal to lose $1,000. Unity has a very low barrier to entry. It's basically what your skill set is what you're capable of doing. There is no learn the engine. There's no like, oh, this is the way things have to be done. It's if you want something to work, as long as you can make that happen, if you need to move an object, as long as you know the math involved, you're good. I mean, it's as simple as adding a couple vectors together and you got moving objects. So it's pretty simple to learn, pretty easy to get into. Another great example, as I mentioned, with Unreal being a shooter, that is what that engine is based off of. Unreal is designed to be shooter first, and so when you start adding things like melee combat or 2D games or things like that, you really have to finagle that engine, where with Unity being a blank slate and not having a specific game type in mind when it was created, you can start pretty much open and you're good to go from there. You don't have to like, oh, well, this sword is actually a ranged weapon with a distance of this much. It makes things a lot easier. And one of my favorite things is the asset marketplace. If you don't have an artist, or you're not a sound engineer, you don't do visual effects, there's a marketplace for it. There are some free, they range in cost, but typically you'll find a lot of really great assets in there to kind of plug in the gaps, fill in the holes. I'll cover a little bit more of it later, especially ones that I like to use personally that go in pretty much every project I use. Unity does have the source code fully available, so you can't go in and change how its physics are done, but you can at least go in and see how they're calculating it. And so that gives you the opportunity to know what variables and things that need to get finagled to fit your use cases. I personally have never had to go in and do anything with it. I find that it works pretty well without, but for the people that like to tinker, it is available for you to look at. And then, as I mentioned before, 3D, 2D, multiplayer games, all available. It supports all of them. 2D games in Unity are actually 3D games, but with a camera that's orthographic, which means that it has no perspective or anything like that. You can layer sprites and stuff, based on depth, but it's actually really a 3D game with a locked camera. And Unity Cloud Build is really awesome, which allows you can have a GitHub repo or any other source control repo that you have, and then have Unity Cloud create all of your builds for you and distribute them out to any of your testers. So you set up a list of people that you want to get the build, you just crank it off. You don't have to worry about locking up your machine or anything else or having a dedicated build machine. Unity Cloud does it for you. There are some limitations with that about like size of things, which I think right now might be 50 gigabytes, which is typically enough for a project. Most of the projects I have now only range to about 10 of the bigger ones, but I'm not making AAA games, so that might not be an option if you have a 100-person studio. Plastic and GitHub are both fully integrated into Unity itself. It does support version control for other systems like Perforce or Subversion or Mercurial, whatever you want to use. It creates meta files that stores all that information that whenever you push up, you just need to make sure you have that included. And then, as I mentioned before, it is multi-platform. This is the list of all of the platforms, or the majority of platforms that Unity exports out to. I guarantee you, your platform is probably on there somewhere. So to cover it, just to end my spiel about what Unity is and start getting into the core of it, these are all games made with Unity that you might or might not have known. So there's Cuphead, Assassin's Creed for the iPad and iPhone. I believe it's Identity is the specific one. Kerbal Space Program, Ori and the Blind Forest. The city one is City Skylines. It's not actually just a picture thrown in there. And then Hearthstone, which Hearthstone was kind of the big name when it first came out and one of the first games actually built on Unity. So to get started with it, I recommend Unity Hub. Unity Hub will let you download the latest versions of Unity. It creates a nice, simple UI platform for you for downloading updates and the new versions, as well as it stores all of your projects that you've opened in Unity, what platform they were last built on, so whether it's iOS, Windows standalone, Mac standalone, saves all of that information for you, so when you go between them, it will open up on that platform and on that version of Unity that you need. For a lot of indie developers, you don't really need that so much because you're not working off of multiple projects at the same time. For anybody that's going to do it freelance, you're going to have clients that are like, I'm on 2017, I'm staying on 2017, I don't care 2018's out and what it includes. So it makes that process really easy. You will have to add an account. They do offer a free one, which is that up to $100,000 revenue I added. There's no limitation between a free, plus, and pro as far as feature-wise. So a free account's going to get you as far as you need. And in reality, well, there's one limitation. If you use a free account, when your game starts up, it has to have the Made with Unity splash screen banner logo on it. If you upgrade to the other ones, you can cut that out if you'd like to. That's up to you of whether or not $25 a month is worth that investment. You do get some other things, like some training and such, going up, but for $25 a month and the training they offer, it's great training, but you can get something else for $250 a year. So out of curiosity, how many people are here are JavaScript developers? And how many of you JavaScript developers also know C#? So a small handful of you. The rest of you that didn't put your hand back up, Unity doesn't like you anymore. The Unity culture is very much a C# culture. As a couple of statistics here, as I added, Unity script is their version of JavaScript, much like TypeScript is. But as you can see, only 14% of one actually have a JavaScript, or all of the projects as of, I think, last year, only have one Unity script file in it. 85% are strictly C#. Things that you buy from the asset store, typically code things that you find online, are all going to be mostly in C# because that's what they build. That is the expectation mostly when you work in Unity. And then Unity does ship with Visual Studio Community 2017 now. It will install it when you download the package itself. It has some pretty great debugging tools. It has its own Unity tools for Visual Studio, I believe is what's called, which will have all of the methods, expected methods, and variables and attributes and kind of the, what's the word I'm looking for? Syntax highlighting. We'll build all of that in for you so it can represent the other ways. It used to ship with mono development. This is probably more of a Unity insider joke than anything else. Some people really liked using mono development, but there was never really a good reason other than it shipped with Unity. If you're one of those people, you can talk to me later. So to start with, everything in Unity is a game object. A game object is your base building block for your characters, your weapons, your sound effects, your lights, your cameras. Anything that you go into your game will be on a game object in some form or fashion. Which moves you to, Unity uses a component-based system, which is how a lot of your scripts and such will actually live on your game objects. So when you create a player, you'll create a game object for his space in the world, and then you'll create, let's say, a player.cs script, and then you'll drop that player script onto that game object. And then all of the idea is your game objects then are your blocks, and then you build the specific thing that you want for each block. And so a player script might have a movement controller, a health, a death setup, you name it, you'll add it there, and that's how you define how that object interacts within the greater world. Which the base of your script will be mono behaviors. Mono behaviors, by default, their class name has to be the same as the file name. You can build other classes inside of that file itself, but if you have a mono behavior that you want to attach to a game object, they have to be the same. When you inherit from mono behavior, you get access to all the game object's information. Game objects, by default, their information will have a transform, which contains position, rotation, scale of that object in the world. And then it also lets you access any of the engine-specific things. The way Unity works, and I'll get into this a little bit as well, is you guys are normally used to, a software developer, you're used to a main loop. You're used to the thing that cycles every frame, that updates as you go. For Unity, they obscure that from you, and they provide magic methods that tie into it that you can use to initialize objects, update objects, whatever happens to be. And if you don't have if you're not inheriting from mono behavior, you don't have access to that information. You can call other classes. You can have a class that's not a mono behavior and have a mono behavior call that class and have it update every frame, and you can kind of backdoor your way into it that way, but you have to have a mono behavior to at least get that information. Running coroutines, I'll cover later. That's very similar to the setup of you have to be tied to that Unity loop. And Unity has specific engine message, like on collision, on trigger, on enable, on destroy, things of that nature that you'll need to, if you want to access, like if a sword hits another player to do damage, to access that trigger information or that collision information, you have to have a mono behavior to receive that message from the engine. Which brings me to, as I mentioned, the main loop. Unity has its magic methods. They start at awake, on enable, start, fixed update, update, late update, on destroy. These are just a handful of all of the methods that you're going to run. I don't think you can probably read that image on the side as the text is pretty small, and there's a lot of them. But that is the order of things that get called from the main loop. So when you enter a frame in Unity, it starts off with an awake call. It sends an awake message to all active game objects in the scene to say, run your awake method. Typically, awake and start are used for object initialization. This is very much the replacement for your constructors on your objects. By default, mono behaviors do not have constructors because they're objects created by the engine itself rather than an object that you created through code. So whenever you want to get references to other objects or initialize certain variable values, you'll typically do that awake on start, depending on which or in what sequence you want to run things. Case where you want to run awake is typically finding another game object and another component and getting that reference from them. And let's say you have a UI health bar. And it needs to grab the player component to know where that exists. And then in start is when you would say, OK, update my bar to the player's current health out of his max health or whatever happened. That one. So typically, that's the way that you'll run your constructors and your object initialization. The ones that run every frame are the updates, rendering, coroutines, and GUI calls. As I mentioned before, back in Unity 2, we are currently your GUI calls is how you drew any GUI to the screen. If you had a start menu, it was done through onGUI. If you had debug information, done through onGUI. Unity has since updated its GUI and its capabilities to be more of a what you see is what you get. So onGUI calls now are mostly used for debugging in case you wanted to have some real-time information. You can always use the console as well. There's cases for both, like you don't see the console in game. So if you're something you'll constantly run into, it only happens in build. It's just the nature of game development and all of the extraneous factors that happen. So you'll want a way to output that information so you can see it. And then the reason for updates and coroutines. So the updates are, as I mentioned, run every single frame. Every tick that goes off will send a message out to run that set of code. This is primarily used for checking for input, character movement, all of that stuff, the stuff that you want to run or that you need to have very, very time sensitive. Big thing with games is you push a button, you expect something to happen. If you push a button and it waits a second before it happens, you kind of feels awful, frankly. There's a couple of different update functions that Unity does. The one that is called update itself is basically, it's called every frame. Frames fluctuate in gaming. Everybody wants to talk about how I get 60 frames per second or whatever it happens to be. So if your game is running at 60 frames, it gets called 60 times a second. If it runs at 30, it gets called 30 times. It's not really great for things like physics and things that you want to run on a very specific time interval, which is why the fixed update exists. So that way, fixed update runs at, it'll say it'll run every 0.3 seconds. And so as many frames that have passed in that 0.3 seconds will be how much it increments itself, but only, it'll disperse your calls out across that way, essentially. So you can, for things that you want to be time sensitive, that's the way to go. And then there is one last one for late update, which is basically the same as update, but calls at the end and after the other two. And reasons for you that you would use this would be a camera. An update, you'd want to move a player, have him translate his position 10 units. And so in late update is when you would have like a follow camera that says, hey, I need to be 2 units back from the character at all times. And so you want that character to move before you deal with your camera code, and that is a great way to balance that out without having to worry about, has the character moved yet? And then coroutines also run every frame. They are slightly different. They are the best way to use for a scheduling of certain codes. Say if you make a server call and you wanted to just keep waiting and waiting until that you get back, that is the best way. So it'll run a method. It'll run whatever method you start, and then you'll add some sort of return value, whether it be a wait for seconds. So you could say, do this code, wait 3 seconds, do the code after it. You could do it for the end of the frame for things that need to get calculated. And for next frame, there's a whole variation of these. This is the type of thing that you want to do if you're going to create like a sequence. If you need to run one task and you need to wait for that task to finish and then run back, rather than having to deal with setting up callbacks and actions all the time, you can just yield the one method, wait for it to finish, yields the next method, wait for it to finish. So it's great in an instance of AI where you say, I need to reach this waypoint. OK, I've got there. Now I'll move here, pick up an object, go here. So you can schedule all of those out without having to know exact timing, and it'll run through. So the one caveat to this is that it runs through the method, it'll stop, wait for the next frame to go around, check again, and then keep going back and back until you get back. So that's the reason why it has to be tied into a mono behavior, or a mono behavior has to be the one to run it, because it has to get tied back into that main loop that Unity calls. One great feature of Unity is platform-dependent compilation. I have experience with some Xamarin, and so I know that you can have your core logic between iOS and Android built in Xamarin, and then you build all of the Vue logic separately. For Unity, you can keep all of your logics in the same place without having to create different classes. So one great example of this would be achievements. You know, Xbox has its own achievements, PlayStation has its own achievements, Steam has its own achievements. So when you unlock one, you can simply make a Unity or a define block, which is the if Unity editor, if Unity iOS, et cetera. Say, OK, tell Xbox, you know, this is the code that runs on Xbox because it doesn't exist. You know, the Xbox achievements doesn't exist on PlayStation. So it doesn't, that Xbox code when running on a PlayStation platform doesn't even know it exists. It doesn't get built into it. It's completely compile specific. And so some examples, as I mentioned, analytics, achievements, and specifically editor debugging. So when you're testing and you only want something to be seen in editor and you don't have to worry about it showing up in build, you can block it in with that if Unity editor tag. One instance, great instance I have of this is working on that teen career game. We have shot information that shows every time in the editor. So when I make play blast myself and record from my editor for videos, I can attach that information, but when I go to build it for the actual client or anyone else to see, I don't have to worry about that shot information leaking out. Fantastic for that. And it also works for Unity editors and coding frameworks. So Unity uses .NET. If you are using some features or if you make an asset or something that some people can use and requires a specific version of .NET, you can keep it blocked into it. Or if you have a specific editor version, because it updates all the time, so certain APIs are deprecated in some of the older versions, you can block out your code that way. So all of it's still in the same place. The method still exists where it needs to be. And then this is actually a really cool system that I enjoy. A part of Unity is Scriptable Objects. These are basically class instanced objects that live within the project. And so you can access these classes within the editor anywhere at any time. You don't have to be running the game. You don't have to have a build of it, whatsoever. They just exist. And so this is a great way to keep data stored on an object and then disperse it out. So in the instance that I gave before with the player HP, and here's another one, you know, if the player needs to know what its HP is, the health UI needs to know what it is, and the audio system, you know, updates how frantic the music is when the player gets on low health. All of these can access and look at that scriptable object rather than having that information stored in a mono behavior. And so a mono behavior would only exist when the game is played, and you would have to find a reference to that, whether it's through the inspector in Unity in the editor itself, or whether you're going to call code to go find it. It always has that information, but with a scriptable object, you can store that information inside of that project level, drag it into the inspector, and then when the player has take damage, that object is immediately updated, and the rest of them can run as needed. And you can build instances, all of your call, any instance of it in there. So if you want to add callbacks on unhealth changed, whatever, all of them just know it exists and can update as properly. They are fantastic for removing singletons. Because they are project level based, they are basically static or global. So there is no more player manager.instance.health. You can add your object, good to go, drop it in. No need to find anything at runtime. So it's great for removing all of that extraneous code, and you don't have to initialize singletons all the time. Another one is for object configuration. You know, if you've ever, I think in Grandma's Boy, where it's like, well, maybe if we turn the elves on level 5 to red or something like that. I don't remember the specific quote, but this would be a great way to do that, where you can create a goblin scriptable object, store in its material information, its color, its weapons, whatever it happens to be, create a new one, and you change up that data and just swap it out. So it's simple, great way to build all of your assets within the project itself. You don't have to worry about importing a JSON or downloading it from anywhere else. Gives a lot of control to designers themselves. As a person that works with non-technical people on a constant basis, you don't want them touching your stuff. You don't want them running, a server run and updating things and potentially breaking things. So everything, scriptable objects keep everything within the editor, within a space that they know. Going back to the decoupled architecture, that's what with the singleton and any other class that you want to do. And then the nice part is they are serializable into JSON, so you can have a game configured to a specific set. It's got 3 players. These are the players' information, et cetera. So you can serialize that information back out if you want to load it back at runtime or just have it for analytics purposes. Here are 2 great talks about how to use scriptable objects and the way that they've changed things for other people. I will go through these pretty quick. So some of the very specific attributes in Unity are serialized field, which you can use. It's kind of a very taboo thing of mine, where to expose things to the editor, it has to be serializable. So by default, a lot of people make variables public. And when you do that, obviously it exposes that value to other classes. And then when you have your junior developer come back through and they're like, hey, I can change the player's health. And you're like, no, you really shouldn't. Or a designer do that. It causes a lot of issues. So instead of doing things public, you can make a variable private the way that you would want it to be and to keep your class clean, but add it as a serialized field so that you can change it within the inspector. Moving to formally serialized. This is awesome for when you're refactoring your code and if you want to rename a variable. If you rename a variable in Unity and then when it recompiles, anything that had that old name, that data is now gone. So if you change the player's speed from 5 to 10 and you wanted to rename that variable from speed to move speed, when you do that in Unity before, it would drop it back to 0, whatever the variable is initialized to. You lose all of that data. So formally serialized as prevents that from happening as long as you put in the last variable name. It'll retain that information, and then you can delete it and get rid of it afterwards. Tooltip, it's exactly what it sounds like. You hover over a variable, and you can put your own information in there. Traditionally, if you don't have this, it just doesn't do anything. So if you want to put like a comment for a designer about a value that it should be, or don't do this with it, that's a great place for it. Range is another great place that you can use on integers or floats to say that this is supposed to be 0 to 1, 1 to 100. You don't want a character moving at 50 units of speed when 2 is plenty. So it provides a slider in the inspector for designers or anybody else to keep that value within that constraints. Now you can change it in code later, but that's your own fault at that point. Hide in inspector. Oh, I went too far. Hide in inspector will have your public variables, as I mentioned, get exposed to the inspector by default. Hide prevents that, just as it sounds. So for anything that you want to have public, but you don't want people changing with dials or anything of that nature, it's when you use that. And header is just for cleaning up the way that the inspector looks and say, hey, these are my move variables, and these are my attack variables. So the next fun part of Unity, it does provide a fully extendable editor. You can create custom windows and what are called inspector views. So custom windows are great for, if you have your one game object and you know that a player requires 10 scripts attached to it, you can create a quick editor window, say, drag this on, hit this button, now attach all 10 of these scripts. That's just one example for the way that it works. I know a lot of people use it for if they need to jump between scenes quickly. So they just build buttons, click on it, loads the scene, move to the next one. Inspector views are more about on the component level. So every component, every mono behavior that you build will have itself drawn out into the inspector when you attach it. So if you want to have a custom view for, say, one that I would use in every project is adding simple buttons to the transform component that an object has to reset it to 0. When you make a child object, when you drag and make a child to another object, sometimes you want it to take that position in the world, or you want it to reset its rotation, its scale, whatever it happens to be. Those are quick and dirty ways rather than having to hit 0 tab, 0 tab, 0 tab. So And my other favorite one is reorderable lists because they don't get created until runtime. So if you have a list of objects that you want to add and you're like, no, this needs to come first, say a wave of enemies you want to spawn. If you play test, you decide that I don't like wave 2 being wave 2, I want it to be wave 5. You have to make a custom inspector, but you can create that reorderable list, drag it down, and it's a quick and easy way to update it. So go back over the asset store. These are my favorite ones. This is a quick video that Unity did to demonstrate its its sales pitch of the asset store, which is it's about $250 worth of assets that they have that they're using in there, but they got a fully run prototype in 8 minutes. In that example, it's kind of a classic Zelda setup where adventure game, you run around, you smack things, they fall over, they die, but that's a great example of how you can use the asset store to get things running and get things going quick. My favorite ones that I have in everyone is Odin Inspector. This is a updated inspector look than what you see in Unity, and one of the big complaints that most Unity devs have is that you can use lists, you can use arrays, but you can't see dictionaries. Odin Inspector fixes that. They have a custom component, custom class that they have for dictionaries. So now you can see what information is actually in your dictionary at runtime, rather than having to do like a debug or a console write. Rewired is fantastic if you're looking to get into console games, especially if you're porting between PlayStation, Xbox, and PC. This retains all of it and makes a single interface that you can use and tie into, where you don't have to worry about having a lot of custom code of, did I push the X button on PlayStation? Did I push the X button on Xbox? It just says, this is button 1. And it handles all of that logic information of sending it out to the proper controller. Do tween and iTween in games. You're going to want a tweening engine of some sort. It makes moving objects a lot easier and cleaner, rather than having to worry about a variable being updated from 0 to 1. It offloads all of that information for you. So great for UI. I know people that have actually built full character controllers off of tweening engines. Not my style, but to each their own. And I'm an organization junkie, so I like rainbow folders. It basically, when you see all of them, it gives them a color or an icon or however you want to specify it. So that way, if I'm looking for my code folder or my art folder, I don't have to just go searching through 15 folder names. I can just find the green one. And then this is the last slide. If you're looking to learn more, Unity tutorials are fantastic. I highly recommend them. Even if they do not cost anything, like I had mentioned with the plus one, that's a certain different set. But if you're looking to get started with Unity, that is a great place to start. Quill 18 Creates is a YouTube content developer who does a wide variety of specific game types. So if you already know programming, you just want to get your hands wet, you just want to build the next Diablo or base building game, Quill 18 Creates probably has a set of tutorials that you can watch that he builds it as you go. So it's a great place if you want to have an idea but don't know where to get started with it. Brackeys is very similar, but kind of the more casual market. It's kind of like your one-tap, one-click games. And these two resources are art assets. Dev assets is fantastic. It's professional dev or professional 3D artists that provide their assets that they develop for pay what you want. It's entirely free if you want. They're actually really good quality assets, which can be hard to find sometimes. On the asset store, you can pay, or Turbo Squid or anything else, you can pay an amount and you don't get anything for it. Or you get something that's not very usable and you end up having to edit it and make it usable for yourself anyhow. And open game art, this is more for anybody that's looking for 2D artists. It's got tons of things, but a lot of that stuff there is sprite sheets and sounds and UI elements that you can use. So that is basically the basics of looking at Unity from a programming standpoint rather than just as a general. So anybody have any questions? I think Justin needs the mic.
You mentioned the importance of having something to do tweening for you. I'm unfamiliar with what tweening is exactly. Could you explain that a little better?
Tweening in this case is taking pretty much lerping a value, linear interpolating a value from 0 to 1, 0 to 60, or if you're going to move a character, from this position to that position. So it in the way of like Flash or anything, it basically it's all of that information in between.
Thank you.
Yeah, so my question's on, so I used to use Unity way back during the GUI days.
Right.
And I actually stopped before they even put the 2D in. But so a lot of this stuff is like, oh, I actually might use Unity again. But I'm curious, did they add in any networking type like stuff for you, or is it still you have to build your own?
So they added in what was called UNet. They're actually currently phasing it out and putting in a new networking layer. They haven't revealed the information about what that new layer is going to look like yet. But there are a lot of outside resources like Photon or Bolt that you can add into your project for networking and multiplayer.
So the engine is based on Mono. Do you know if there are any plans to migrate that over to .NET Core?
To which one?
The .NET Core.
I don't know their exact plans. I know they were talking, they're still stuck with Mono. The last I heard that they were looking at changing it to Roslyn. Outside of that, I haven't heard any other information about what they're moving to.
Does Unity have anything similar to like Unreal's Blueprints system?
There's talks that they're going to be adding a visual scripting setup. There are a good number of asset store plugins that you can purchase that do it. Playmaker is a popular one that comes to mind, but there's nothing in the engine by default at the moment.
So I asked because I was wondering if you've ever encountered having to work as a developer in a project where they were using something like Playmaker, so kind of interacting with the visual scripting as a developer.
Yeah, so the teen career project that worked to add some clarity. Unreal has a system called Blueprints, which allows you to basically create code blocks and connect them together to create logic rather than having to write the code itself. In the career path that I'm working on, we're actually using a plugin called Adventure Creator, which is not as verbose as Playmaker is, but it basically provides a visual scripting system for its own features. So Adventure Creator in this case works with, if you guys have played Telltale games, The Walking Dead is one of their big popular ones. They've done Back to the Future, Wolfman, Game of Thrones, a bunch of other ones. They actually just went out of business, which is really unfortunate. But it's a very similar system to that. So it provides a scriptable system of like, move this character here, have this character hold an object. I have worked with it. I like it personally. I think it adds a lot of speed to it, but from my experience with it, there needs to be more of a reuse. I think that's one of the big downfalls of visual scripting right now is constant reuse. We make modular code. Why can't we make modular code blocks?
We've got time for one more question. The very last question gets a Chadev sticker for motivation.
Apparently, you need to up the ante.
All right, I've got one question for you. Two-part question. What was the first production game you wrote, and is it still in production?
So the first game that went to production was a Facebook game for CSI. I don't think it was just a CSI thing, all-encompassing. It wasn't a specific version. You basically searched crime scenes. You had to investigate each little tile on a grid to figure out where evidence was, and you had to complete the map before, or you had your energy bar, so you got to search like 10 at a time. I don't know if it's still in production or not. I haven't looked at it in a while.
How long ago was that?
This was 2011. So I kind of, when I stopped making Facebook games, I stopped playing Facebook games. So I haven't gone back since.
Awesome. Well, thank you. We'll see everybody next week. With a friend. Thank you.